Okay, this first integral, like the previous examples, does not have a positive or negative infinity as a limit of integration, so it's not obviously improper from that. If you actually look at the function itself, though, you can see why this is an improper integral, and it scores the importance. You really need to check what you're integrating before you just take an antiderivative and start plugging in. So if you look at this, the denominator would be 0 if x equals 27, and 27 is one of your limits of integration. So you have an asymptote at 27, and you're doing the definite integral up to that asymptote. So this is improper. And if you look at the interval that you're integrating on, you're going from 0 to 27. Here's the asymptote. So you're going to be actually approaching 27 from the left-hand side. So that means we're going to be doing the limit as c approaches 27 from the left, the integral from 0 to c of the dx over the cube root of 27 minus x. Now to integrate this is u substitution. U equals 27 minus x, so our du equals a negative 1 dx. But if you look right here, this is a positive 1 dx, not a negative, so we have to counteract that negative with another negative. So we are really integrating a negative u to the negative 1/3 power du. So when we do the antiderivative, we'll use the power rule, add 1, so u to the 2/3 divide by the 2/3, so it's multiplied by 3/2, and we have a negative 3/2. So this becomes the limit as c approaches 27 from the left, and this is a negative 3, and then our u is being squared with the cube root, so we have a 27 minus x squared over 2, and that is from 0 to c. So now we'll actually evaluate at our limits of integration. This is the limit as c approaches 27 from the left. We have a negative 3 cube root of 27 minus c squared over 2, minus, but it's a negative, so we'll change it to plus, 3 times the cube root of 27 minus 0 squared over 2, and evaluate our limit. So we're approaching 27 from the left, which isn't really, from the left isn't really affecting this because our 0 that we're going to have here, 27 minus 27 is 0, is in the numerator, but also because we're squaring it, so it's positive. So we have a 0 times negative 3 is just 0 divided by 2. This whole thing goes to 0. Looking at this, we have 27 minus 0 is 27, and we're squaring it with the cube root. I would do the cube root first. The cube root of 27 is 3, squared is 9. So this equals 3 times 9, divide by 2, and that is 27 over 2 as our answer. This problem is probably the least obvious for improper. If you look at it, we don't have a positive or negative infinity for our limits of integration. And if you plug in 0 and 3, if you evaluate your function at 0 and 3, you don't have an asymptote there. But looking at the function, you do have an asymptote when x equals 1. 1 makes the denominator 0. So if you look at the interval for this one, we're integrating from 0 to 3, and we have a problem at 1. So what that means is that you're actually going to break this up into 2 definite integrals. We're going to go from 0 up to 1 from the left, and then we're going to go from 1 from the right to 3. So that means I'm going to have 2 limits going on. The limit as c approaches 1 from the left, and we'll integrate from 0 to c of our dx over the cube root of x minus 1 squared, plus the limit as c approaches 1 from the right, and we'll go from c to 3 of the same function. So actually doing the antiderivative of this, it is u substitution. Our u equals x minus 1, our du equals 1 dx, and we have 1 dx, so we don't have to do anything to counteract that. So we are integrating u to the negative 2/3. It's squared with a cube root in the denominator. So when I use the power rule to integrate this, I'll add 1, so I get u to the 1/3, divide by my new exponent, so that makes it a 3. So it's 3 times the cube root of our u. So this will equal the limit as c approaches 1 from the left, and then we have 3 times the cube root. Our u was x minus 1. That's from 0 to c, plus the limit as c approaches 1 from the right, 3 times the cube root of x minus 1 from c to 3. And some people will use a different letter because you have two different limits going on, but as long as you can keep them separate, you're fine. So I'll actually plug in my limits of integration, and this is the limit as c approaches 1 from the left. I have 3 times the cube root of c minus 1 minus 3 times the cube root of 0 minus 1 plus the limit as c approaches 1 from the right, 3 times the cube root of 3 minus 1 minus 3 times the cube root of c minus 1. Now evaluating my limit, c is approaching 1, 1 minus 1 is 0. Again, the sign doesn't matter because it's in the numerator, so this just goes to 0. 0 minus 1 is a negative 1. The cube root of negative 1 is negative 1, so this is just a positive 3. Negative 1 times a negative 3 is 3. Plus 3 minus 1 is 2, so this is a 3 times the cube root of 2. And then c is approaching 1 from the right, so 1 minus 1 is 0. Cube root of 0 is 0 times negative 3 is still 0. And 3 plus 3 times the cube root of 2 is the final answer.